Hello, in this video we are going to talk about the physical parameters that affect the runway and the corrections which need to be taken into account if we do not have the design manual of the airport of a given aircraft. For starters, in the design manual of a defined aircraft we have some tables as so. Wait a moment please. Here they are. In the design manual of the 320, we have some tables of takeoff weight, runway length, altitude, and here is in function of the temperature, but if we do not have that we can apply standard corrections. First is the definition of the aerodrome reference temperature that ICAO defines, that is the monthly average of daily maximum temperatures corresponding to the hottest month of the year, this being the one who has the highest monthly average temperature. What does this mean? We take all the months of a year, we do the average temperature, the one that has the highest average temperature is taken, and we take all the maximum temperatures of all the days, we do the average of these days, and that is the mean that we have to use. We should use several years in case a year is especially hot or especially cold, and we have the aerodrome reference temperature, which is the one that we are going to work with. What is this used for? The aircraft at the time of takeoff or landing needs more or less runway in function of several things. One very clear is, for example, if it is tailwind or wind coming to the nose of the plane. The other is whether the track is wet, therefore will take more to curb, or if there is ice. There are a number of things, atmospheric, that affect the length and the configuration of the runway, and for these are defined as standard corrections. If there is more altitude, we will need more length because the air is less dense, less lift, we need more runway. This affects both to land as to takeoff. If we have a higher temperature, the air is also less dense and affects us to land to take off, but studies show that affects much less to landing for the configuration of the plane, because in the landing distance a correction parameter has already been taken into account, and also because one of the things that makes the temperature is to affect jet engines. Because in order to obtain a power, a jet engine works with the temperature difference between the combustion chamber and the outside. If the temperature is greater, the reactor has less power, and when we are landing the engines are working in idle. Actually, we need the power of the engines in the takeoff, so the correction for temperature applies only in the takeoff. Furthermore, in runways of more than 900 meters, we apply the correction for slope, because obviously if we have more slope we will need more runway to accelerate. Here we have the data, a 7% for every 300 meters elevation in both takeoff and landing, 1% for each degree that the temperature exceeds the temperature of the atmosphere ESA for that altitude. This is only used in the takeoff. The ESA atmosphere has a formula that says that is 15 degrees at sea level, and it reduces on the basis of 6.5 degrees for every 1,000 meters up to 11,000 meters. Then we have here a formula that we can use to calculate the temperature and to calculate the difference with the aerodrome reference temperature and to know the correction. If the combined effect of these two is greater than 35%, there must be a specific study, and finally, if the runway has more than 900 meters, for each 1% of slope we have to add a 10% of correction in the takeoff. All of these corrections we will use later. First we are going to see here the formulas in meters. A 7% per each 300 meters, 1% per each year is not incorporated the formula of the atmosphere ESA, and a 10% for each degree by each 1% of slope. This has to go in a percentage. But if it is not in a percentage, it will be necessary to multiply this formula by 100. Here we have the formula, and we have the same formula with feet and with the formula of the atmosphere ESA. If you want to use this formula with meters, instead of 984 will be in 300, and instead of 3280 will be 1000.